Hello, everyone, and welcome to today's SANS webcast, Navigating the AppSec Alert Overload, Strategies for Effective Application Security Monitoring, sponsored by Oligo. My name is Mary Lynn Gollier of SANS. Today's featured speakers are Gal Elbaz, co-founder and CTO at Oligo Security, and James Berthoy, Senior Cloud Security Engineer at PagerDuty. If during the webcast you have any questions for our presenters, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Thanks, Marilyn, for the great introduction, and thank you everyone for joining us today for this amazing webinar, and thank James and thank everyone for being here. So we're first gonna briefly talk about the pain and to really show how real it is. And I just came back from DEF CON and Black Hat, and it seemed like this is the theme of the conference, and everyone was talking about it, and this is just demonstrate how big this pain is. So we're gonna quickly go over and see just the numbers that support it and really deep dive into the alert overload that we're facing today in the AppSec world. So when we talk about alert overload, this is insane to just see the numbers that speaks for themselves. The amount of security alert is just on the rise. And as you can see, like, we're already overwhelmed with this amount of noise, and it's quickly become pretty impossible to deal with all of it, both from the security perspective, but also from the development perspective. And we can see that there is an average of 100,000 alerts per day. And actually, when you give me so much alerts, it's just like giving me nothing, because in the end, I need to take action and work on it. And of course, this is just the beginning, because absurdly, most of their alerts aren't real. And it's insane to see that the numbers here, they're like 85% of their alerts are actually not exploitable. And we're talking about risk perspective. In the end, we really want to understand what's the true risk, and without being able to understand, okay, I have an alert, it's actually theoretical because it's been scanned statically, but when I actually want to see if there's a real risk, I want to know if it's actually running or loaded, because if not, it cannot be exploited. And hence, this is just a false alarm that it's taking me away while I manually investigate it. And while I do that, I actually neglecting the real issues themselves. And of course, this friction is in the end affecting both the security perspective, but also the development. Because in the end, okay, when we do have this alert, and there's, again, so many, but a huge portion of them is just actually not relevant, then when we just take each and every problem and we try to look at it from the perspective of okay, how much time it actually takes to fix or to resolve this issue, there's again the human factor, and we see that it takes a lot of time. This is the average, 6 days to fix the vulnerability. Usually, I say, it really depends on the complexity of the organization, how things are handled. But even if you take this simple 6 day and you multiply it, but the amount of time that go to waste on chasing after those false positive, you just see how much wasted time just interfering your engineering in both your security teams, but also you're just choosing the wrong battles. And of course, just to add a little bit more complexity to the already very complex problem, in the end, there is only a limited amount of security engineer in the R&D organization. We can see the typical ratio, 1 against 100. I saw even more, and James can elaborate more on that. But in the end, it's nearly impossible to really tackle all of this problem. And then to add a little bit more difficulty, now we're from the security perspective, always under the impression that we need to deal with all of it. And again, we're in a shortage of manpower, so it even make it look a little bit harder than it seems. Then there's so many out there, but hey, we're so few against so many problems and people as well. So we talked about like how there's a lot of noise that is coming from this static scan, because the fact that we are only theoretically looking at the risk, but we can't know what's practically impacting our environment. We can just imagine how this amount of vast noise and irrelevant alerts falls on the already overloaded teams, creates a situation of like wasting so much resources. But this doesn't mean that like there aren't real risks. And I think Log4Shell, it's like the biggest testament that even up until today, even when we have so much noise, even that there's a lot of confusion around that, still we see that there is a huge risk even in one vulnerability in one package. And that's why it's insane to see that even today 72% of organizations are still vulnerable to the Log4Shell, because it can get so from so many places, from your homegrown code, from your third-party tools, from the stuff that you buy or build or deploy or whatever. And this is why we can see that there are still teams that even after they thought that they actually solved the problem, they get reintroduced to the vulnerability in so different way. And this is still a huge problem. So while we're actually really trying to focus on what's real, and there's a lot of false positive, it's really important to also pay attention to the fact that there is still a huge risk out there, even in one vulnerability in one package. And of course, we have to look at the last year. Like, of course, this is a known problem from the early days that software was starting to really change the industry, and people were starting to talking about those risks. But even these days, with so much noise, we often lose sight on what risk really matter the most. And there is a true risk. Look, only the last year, like from Log4Shell or Text4Shell or Spring4Shell or everything with Shell that came to our life, and we need to deal with it. But moreover, there are other perspectives like colors and faker was kind of like an OSS terror, as people look at it, or OpenSSL that gave anyone a little heart attack in order to really validate if it's actually impacting us or not. And of course, the famous PyTorch got abused by a dependency confusion. And it's all, again, only in the last year. So it's important to mention that while there's a lot of noise, there is still a lot of risk in those areas when we talk about open source security. And this is the great testament for everyone to see. So that's why we can't ignore this AppSec noise, but we just need to really focus better on the real risk. And now it's time for to get started. So Daniel, I'm passing it to you so you can lead the discussion, and we can deep dive after we have a quick recap about the problems that are facing today.
Awesome. Thank you, Gal. Thank you for setting the stage. And if I can ask you to close the Zoom sharing at the meantime while we are having the discussion. So, hey everyone, I'm Daniel and I'm part of Oligo's marketing team. I will be the moderator for today's discussion. So, as Gal mentioned, today's challenge isn't just around finding vulnerabilities, but figuring out which ones need our immediate focus. And with so many alerts coming in, it's easy for the real threats to get overlooked. And that's exactly the issue we're addressing today. So together with our expert panel, we'll explore practical strategies that businesses can employ to manage application security alerts more effectively. So let's get started. James, I'll start with you. So first, I would like to get a quick introduction. And also, given your experience and impressive hands-on experience at PagerDuty and other large-scale cloud infrastructures, I would love to walk us through how you prioritize the flood of AppSec alerts coming from code scans, and how do you keep the balance and the urgency of addressing certain vulnerabilities against, the sheer volume of alerts that we receive today.
Yep. Thanks so much, guys. Hey everyone, my name's James again. So my background, just really quickly, I think it really speaks for, I'm assuming, a lot of people on this call, where I was sort of in the systems, help desky, sysadmin, doing some Linux stuff kind of world. And then cloud got kind of thrusted onto me, right? Where all of a sudden there's a CISO whose literal description is go figure out what the devs are doing in the cloud with the CTO's credit card and start securing it. And so really a lot of this problem is because people are working backwards with very little context. And so it creates a really confusing environment for a lot of teams, as their engineers are still learning the nature of not just cloud, but like, how does a development workflow happen? In the meantime, devs are like getting onto Git version control, and open source is becoming more and more prevalent. And so it's really this perfect storm of trying to rapidly advance skill sets, toolings, processes, new people involved. And so it's all a very rapidly evolving issue. And I'm really grateful that a lot of this time I was at ReliaQuest as this transition was happening, because as a detection response provider for a bunch of companies, a primary service that they offer is security operations. And so it's sort of being at the front lines of all of a sudden security operations teams are receiving alerts for an old version of an open source software. And that's just not something that security teams had ever seen or really dealt with in their normal purview, because that would be relegated to like an application security team that was only in-house at like the biggest organizations, like giant e-commerce centers that have a financial incentive to securing their application. Whereas many other companies just don't have that financial incentive to really lock down things like, how can we make sure that someone doesn't buy a product before it's supposed to be released? And so they hadn't made the investments into application security specifically. And so really cloud has just become this umbrella for all of these different alerts and noise. And the biggest thing that I noticed right away is that the SOC really cannot deal with these configuration alerts, is the way I think of them, where the fundamental problem that was happening, that still is happening with people who are early adopters, especially of like CNAPP tooling, is yes, cloud native application, let me see if I can do this on the fly, application protection platforms. That group of tooling exists for security teams, and it's what's generating the noise to all of a sudden a security team's getting an alert that a new unencrypted database has been spun up, or a MySQL version that's older than it's supposed to is created in the environment. And that's just a new type of alert that they weren't getting before. And that team can't do anything about it, right? If I'm a security operations analyst, if I get an alert that there's malware on a server or on a user's laptop, that's something I can actually do something about. I can go and quarantine the file, I can quarantine the malware, I can remove it from the host, I can snapshot it, do forensics. I know I have a playbook for that. But to give like a junior SOC analyst an alert saying, hey, your version of Log4j is 2 versions old, and they're like trying to hunt through GitHub repos to see what version they're on, where it's coming from, what's the exploit path, what can happen. It's just a layer of complexity that they're not there for. And so to get to the question, the number one thing that I find helpful is to separate in your head configuration alerting from runtime alerting. And the configuration alerting is the stuff that you want to go straight to your developers, right? And they're the ones who can actually fix and change things. And so your priorities for evaluating those tool sets are very different than the runtime. And so I know I'm going on a lot of different tangents here, but the runtime nature of, there is a runtime component to the SOC monitoring. That's what they should respond to, is there's an exploit attempt. And so to use Log4j as an example, because it really encompassed both of these paths, where the devs needed to be focused on updating to the latest versions of Log4j, but the security operations team needed to be focused on looking for any JNDI lookups, looking for any exploit attempts, blocking it on the WAF, seeing if they can block it within their log systems, checking all of their systems using an asset inventory to see what potentially could be vulnerable to it. And so you really need to be able to do both of those things at the same time. And then a lot of tools in this space, like Oligo, like some others, help really prioritize by showing the runtime context to help inform the prioritization of the configuration scanning. And that prioritization, my advice on that front is you really have to have a clear idea of what the goal of your vulnerability program is. because too often companies come in and say, we have this list of 10,000 vulnerabilities from our shiny new tool that we bought, and we just need to start fixing them. But you're never going to hit 0 vulnerabilities. And you have to have clear goals on, we want to make sure that we are not vulnerable to exploits, to denial of service, to remote code execution, like setting more clear boundaries on what you're trying to protect against, and really creating areas of the application that you're trying to protect the most. So for PagerDuty, for example, our vulnerability program is heavily driven by FedRAMP because we're FedRAMP in process. And so for us, the prioritization doesn't matter as much as like, we have to fix every vuln. And so that informs our program to where we have the goal and our devs are synced up on it. They know the priority for the organization. The security team is synced up on it. We know the priority, and we're working together to have a vuln reduction across the board program. But at other companies I've been at, you have to be realistic about what the goal of your security program is, where we would use something like Oligo, like others, to prioritize and deal with the vulns that are going to be most likely to be exploited, because we didn't have FedRAMP as a goal. Instead, we're trying to adhere to like our SOC 2 vulnerability process, which is really emphasized, how are we protecting our users? And the best way to do that is not to just remediate every vulnerability, but to really prioritize, what are you going to use time on, and getting commitment from across the org to do that. So a bit of a long answer, but I think that hopefully gives the context of the way I think about stuff between the configuration and the runtime.
Yeah, that's super insightful. Thanks, James. And as you mentioned, prioritization is critical, but equally also important, the approach we take to address the vulnerabilities and clear goals of your security. Super interesting. Gal, given your experience in security research, specifically at Checkpoint, what are the common misconceptions about application security alerts, and how do you think these beliefs influence how companies tackle this type of alerts?
Great, Daniel. Thank you very much. So I think one of the biggest misconceptions that we keep hearing really, really often, it's the fact that up until now, people really looked at the risk based on the scoring. Like, okay, I have a critical CVSS score, it's 9.8. It sounds critical. We need to deal with it. But when you actually go into details, like, you really need to pay attention that in the game, we're looking at everything from a risk perspective, because something sounds critical, like I want to fix it. But again, we need to really think deeply and say, okay, but what's the likelihood of that to happen? And even if it's like 9.8, like it's 10 out of 10, but like the likelihood is 0, it still like doesn't impose a risk to me. And that's why we need to change the way that you look at that risk and look at other risks, because again, there's so many to do. So I often hear this misconception of like, I have to fix every critical because it's critical. And then when we really dive in, okay, but if this critical is never been used or never running, so it cannot get exploited. So would you look at it still as a critical vulnerability? Is it more important that a high vulnerability that is running the vulnerable function? So maybe not. So we need to rethink the way that we're looking at risk, and we're basing all of our assumption on scoring that is very generic. And I think the first question, like exactly like James said, okay, I have a new risk or a new threat, but like, how does it really affect my organization, my application, my needs? Because again, CVSS score is a generic stuff, but knowing how I use it or if I use it, and given this context, given the likelihood of that to happen, it's another level of knowledge and risk perspective that we need to get in place to our prioritization program. Because in the end, in theory, like you said, James, we want to fix everything, and you have FedRAMP, it's different. You're gonna take different approaches, maybe remove those that code that you don't want to really upgrade or fix because it takes a lot of time and you take different measurements. But when we actually look at this from like the perspective of like, yeah, I don't want to just get clean dashboards. I actually want to detect and really manage my risk. So there goes these aspects of like, what's the real scope of impact, how it's really impacting me, and what's the likelihood of this to happen. And these two important questions can only be answered from the environment of the organization, from the real application, from gaining the context and telling you for each and every one, okay, it's a critical vulnerability, but okay, it's actually not running. Or is it running, but it's not running the vulnerable function? Or even if it's running the vulnerable function, but it doesn't have the ability to control the parameter, again, we will need to adjust the risk based on our usage and not just take as granted to something that is, again, very generic and worldwide. And it was a great start. But today, in the current changing landscape, we need to really rethink the way that we look at risk.
And here's something that I think is super important about the way that you categorize that is a lot of vendors in the CNAPP space are pitching that same contextualization pitch, but they're focusing on the infrastructure architecture because it's what their platforms are based around. But everything you described was based around the usage of the package in the code. And that's why fundamentally, like, so much of the marketing in this space sounds like it's the same thing, where it's like we're doing prioritization and contextualization, but something being like reachable from the internet or not doesn't usually determine like, could this vulnerability be exploited or not? And so usually that requires a lot of the nerdy details of, because even if you think about each of those major exploits that you showed on the slide of like Spring4Shell, Log4Shell, Colors, like those all had very specific different exploits and remediations and contexts that it's really hard to, people want a tool that's going to answer all that stuff automatically for them, but it really requires a lot of digging into like, what are the details of this CVE and this exploit to know? And the struggle organizations are running into is there's just too many CVEs to go through to think of it that way. And I actually wanted to ask your opinion on, right now I see a lot of buzz on like CVSS scoring and like if it's outdated or we should switch to something better. And I was wondering your thoughts on that, if you had any.
Yeah, James, thank you for always being so awesome. So you touched exactly the most interesting part. And as I view it, I think CVSS was a great start and a great beginning to look at this risk perspective. But as you mentioned, we need to add more and more parameters. And I like the way that you differentiated it because the world has changed. Like back then, all we knew was like, okay, we're scanning repos, we're scanning code, we have CVSS score, and this is all we had. But then really smart people added the context of like, hey guys, like we wanna really prioritize what's most important. And if something is getting exploited out there, it's most likely to get exploited in here as well. And let's add this part as well. And you saw how the industry has changed and also add the exploit maturity, or today the EPSS score. So I think that today when we're moving to the cloud, so okay, back then we had repo, but now we're taking this repo and we're shoving it into a container that, like you said, so come with its own package and its own vulnerabilities. But here it's where we need to differentiate, because what James talked about, and it's also super important when you prioritize, to add the environment context. Is it internet facing? Is it communicating with data? Is it in a privileged container? Given the context of how an attacker will look at it. But as James mentioned, now we also need to add to this parameter scheme also the application context, showing what's actually been used. Is it running? Is it running the vulnerable function? Is it like which parameters are being used? And adding this combination of all of the parameters, it's what I think will make the prioritization from something generic, that this is what we use today, to something that is much more tailor-made to the organization, to its own application, tailor-made to its own needs, and then change it according to the policy. Because let's say, like, James, an organization like you said something super nice. Like for me, it doesn't help to say if something is internet facing, because everything that I use is internet facing. I serve so many customers around the world, and for me, this environment context doesn't help. And this is exactly the point. Like we need to make this prioritization tailor-made to each and every organization needs, and that's why the way that I view it is that if we could have all of these parameters that we all agree that are smart and we need to take action upon, it might change the score that we give to stuff, and we aggregate all of them, but also give it in the context of the same organization, same needs that are tailor-made to your application, this is what will make the prioritization really, really straightforward and really pinpointing you to the real issues that you need to deal with. So thank you for that, James.
I think a good example of that is like, first of all, I think it's very funny that a lot of people's reaction to Log4j, I'm assuming, was like my own, where it's like, oh, we're not vulnerable to this one because we're still on Log4j 1.x. So we don't have the 2.x vulnerability. But that I remember, like, the 1.x stuff all required having an Apache chainsaw setup in there, and that gets to the kind of, like, right now there's no tool that's like no CNAP type tool is what I'm thinking of, that is saying not just that like this is web facing, but like actually looking at what's hosting it and seeing if, like, is there an exploit available for an Nginx load balancer to get to this through that. And so that's why there's a lot of assumptions that have to be made with those like prioritization scoring that's not really related to the app.
So I want to touch again on Log4j. Obviously, we can't skip this topic in any application security or even any security webinar. So given the crowded landscape of cybersecurity tools out there, why do you think we were taken by surprise and didn't have any immediate solution? And what does it say about our readiness for these type of challenges we face and for such a devastating vulnerability?
Yeah, I think fundamentally Log4j was just the first big showing for this kind of open source exploit, where other things had happened in the past, but just the ease of exploit here was so vast. And then realize it's the first time, like, a lot of people were experimenting with SCA, software composition analysis tools, but they never had like a gun to their head while they were doing it, in terms of like, if you don't fix this, like, you are going to be exploited because there is something actively attacking. Like, I even think about this with stuff like public S3 buckets used to be able to sit on the internet for like maybe a week or two before they got popped, but now it's like every hour you're going to see different aggregation tools, different exploit attempts. Like, the speed of attackers and automated scanning for this stuff is hitting a point where you really do have to remediate fast. And so it's that, and I'm hopeful that a lot more companies are allowing their developers to actually contribute to the open source projects that they're profiting off of, to be frank, where really getting this stuff fixed. Like, it's embarrassing when I see people post like, tool X discovered this CVE in your open source repository, like, please let us know when you're going to fix it. Like, that's just some guy maintaining the repository. Like, he's under no obligation to fix your random false positive that your tool discovered. And so really, I think there needs to be a much more conscious adoption of what open source tools are we using, and are we willing, we've used them so much to go fast as an organization, are we going to allow our developers to contribute back and maintain those projects, even though it might slow us down by a week or two? Just super important for keeping things up to date when they need to be.
Definitely, and James touched exactly those points, because Log4Shell was so devastating due to the fact that it was basically everywhere. It doesn't matter if like we have it in our repo, because if not, probably one of the tools that we deployed or bought have it, and in the end, it's part of our organization. It's another application that we need to secure, and hence it was just everywhere. And the way that I look at Log4Shell is in two different perspectives. First, it really enlightened the problem that, okay, we have a risk, like this is like not a critical issue that we need to patch. This is like going way to okay, there's an incident. And in time of incident, the way to respond and to fight the threat, it's first of all super crucial, because in the end, we're talking about a time critical. Like, we know now it's getting exploited, like, and frankly, like James said, like, one of the biggest problem there was that the ease of exploitation. Any script kiddie with access to GitHub could run the exploit and take over like basically every Java server on the globe, because in one way or another, by a transitive or non-transitive dependency, someone used this logging mechanism that was so fundamental. So I think the first problem space that when we're very crucial in the time aspect, one thing that really emphasized the biggest problem that came out of Log4Shell is first like the response. Okay, where is it? Okay, we're gonna scan the repo, we have our scan results, but then wait, doesn't mean like where it's actually impacting its runtime. So then like a lot of people try to do network scan results or try to do container scanning, but again, it gives you the context like where is it? But again, without the ability to know, actually it's actually running, it's running the vulnerable function. Like James said, does it have the configuration that make it vulnerable? Like, or the opposite. So it was really hard to really scatter even if it was one vulnerability in one package, it was everywhere. So just really understanding where to really focus our resources first was the first issue. And then when we're talking about, okay, now we need to find the risk and send our teams, but what do we do in between? Like, or like James said, like we're taking it for granted, but those amazing people that built the open source, they're not working for us. We took it for free. And like, we cannot tell them, hey guys, you have an SLA, fix it. No, like we need to say thank you for them and maybe help them as a community. And that's why even like Log4Shell was an example, but a lot of time we don't have a fix. Or in Log4Shell, it happened, we had a fix, but then it was bypassed. Then it all started again. And then this is really emphasizing another problem of actually, okay, there's this vulnerabilities is readily exploited and now we need to deal with it. But now we're talking about the perspective, like the runtime perspective. Can we detect the expectation attack? Like, can we, while we're sending our team, can we be sure that it's not getting exploited? Or could we even tell how many times did it get exploited, from where it connected to? So we had zero context about the attack itself, about the exploitation attempts. Needless to say, being able to prevent it or to mitigate it. And I think this is another huge problem that we saw a lot of organizations saying like our best solution was just to take down the servers. Because like even if we had the WAF rules, we need to wait for it to happen. There was another bypass where like it was on the weekend of Christmas, and like the best solution that we come up with just to take down the server. And again, when you're taking down your server, meaning you're taking down your application, meaning you're disrupting your business, but it was the best solution in order to really feel safe or like just be on top of stuff and know that like no one is actually taking it to the next level and actually exploiting your application and infiltrating your network. So I think this is like two huge problems that came out of Log4Shell that really put an emphasis to the industry. Like this is like two huge gaps that still needs to be addressed.
Yeah, it's an interesting point too that you're reminding me of now that I'm more remembering what we did in depth as well, where like we had container runtime defense tools when it happened, but because of like those systems are still heavily like signature based or looking for very generic like command line running within containers, really they just weren't equipped at all for it. And so I remember setting up alerts in our SIM from the application logs, just looking for the JNDI query, and then doing the same on the network side with the network logs. And then really you're just praying that you see it at that point. And if you do, that you're going to be able to actually kill the session before the attacker does. And so it creates a very like stressful situation for yourself. And really that just comes down against like the details of, at the end of the day, the thing that's advanced the most with all the cloud tools and the CNAPP stuff, I think application security has really come the farthest because it's forced security professionals to really learn the applications that they're supporting and really think like, how are we getting application logs? How are we doing incident response for our application? But do we have the ability to kill user sessions? Whereas before it was very focused on like, what do we do if an attacker gets on our server?
Exactly. And just to double click on that, because that's super interesting, because James, you just said like what's need to be said. There were like so many runtime tools. Like you had like CWP type of tools that secure infrastructure, and we had EDRs, and you had WAF or IPS or intrusion detection. We had so many runtime tools, and like, how is it possible that still this attack went so broad, and like no tool was out there being able to block it or to stop it? And this is due to the fact that up until now, the way that we looked at application, like each and every tool does its own amazing stuff, but when we start to talk about application risk and application exploitation, all of the runtime tools, this is what we've encountered when like we talk to you about Instagram and give this example, but what we've seen that is everyone look at it, application as a black box. Like we look at application as one whole that if you look at it in this perspective, you just let it do everything. Because let's say I have a container, but one library should communicate with the network, another library should write files, another library should run external code. In the end, when you look at it as a container, as a one black box, we should give it the permission to do everything, because we don't want to disrupt our legitimate usage. But when Log4Shell happened, the fact that like everyone learning the application behavior as a whole, and no one have the level of granularity to tell us, oh, this is my Log4j communicating outside, and this is a logging library, and it shouldn't happen, and have this level of granularity to really understand what's going on. The best thing we could say, it's like, okay, it's communicating, like the container is communicating outside, but it should communicate outside. And exactly like James said, like here, we have to be aware of the details. We have to be aware that the exploitation occurs through the JNDI, and that's why we need to look for this specific pattern on the network, and then we might be able to look for it and really decide if it's malicious or not. But again, in order to do that, we have to be aware. What about the stuff that we aren't aware of? What about the unknown risk? Like, what about like some new exploit that is now taking place, and we don't have the ability to look at it because we look at the granularity level that doesn't let us the ability to really understand what's going on within our applications themselves. So
And that's
super interesting, James.
Yeah, I mean, what I'll add too is like to really just as advice when purchasing tools, because I talk to a lot of vendors, like in your demo, you're going to get here's an example of Log4j and how we would have caught it. But almost none of them are saying like we did caught it. They're just saying like, here's how we would have. And so there's also a lot of smoke and mirrors you can do where like you would think that a lot of the technologies that do like looking at the Docker file and looking at the image as it's spun up in the runtime activity and then like baselining that and looking for deviation, like you would assume that would catch it. But a lot of like what was happening was the package doing what it was expected to do of like writing to a SIM. And then like that SIM then has a vulnerability that's talking back up to the attacker server. And so you wouldn't even notice like to that runtime that's looking for the baseline deviation, it would look like normal activity. And so there's really a lot of like smoke and mirrors that can happen. And really what you have to think about is when it's a balance of the level of granularity you need to actually detect and stop a 0-day is always going to be really complex. And then does that system have a way to manage that complexity in a way that is actually scalable to an organization? Because you could map out YAML files of every file path and every process and what it's doing and lock it in. And then that has to be manually tweaked every time there's a new change. But that's just not going to be scalable for most architectures. And so it's really that balance of trying to think through, is there enough detail here that I know and can trust what's being done? And is it scalable enough that, like usable enough that I can actually realistically maintain this? Or else you're going to end up in the 100,000 alert territory. Yeah.
Guys, I would like to shift the gears a bit and discuss people and dynamics between teams, because no matter how advanced are the systems, if the human element isn't in sync, AppSec can't actually scale, which is also perfectly leads into the age-old debate of how security teams and developers can collaborate better. And there has always been a debate about this collaboration between the teams. James, I'm curious to hear, how do you effectively partner with developers when addressing application vulnerabilities? And is there a distinction between tackling issues early on, which is on the left side, shifting left, versus later in the life cycle?
Yeah, I'll try to answer this from a few different organizations, because honestly, I didn't think such a good relationship could exist until coming to PagerDuty. In terms of like, our dev culture is really, really good. And I think a lot of people on this call probably have dev cultures that are more like curmudgeon-y, I'll say, is like the developer attitude towards security most of the time. And it's once you get more into this stuff, you'll understand why your developers are curmudgeon-y about this stuff. It's because there's some, they're tasked to build this new feature for product, and they've got all this tech debt they'd rather be fixing anyways. And then all of a sudden security comes along and says, here's the CVE you have to fix. And then you're reading the details of the CVE. You're figuring out where it's coming from, if it's a transitive dependency or not. And like, it's really just, it can easily researching, if your research into a CVE becomes basically requiring you to create a POC of the exploit in your environment, like that's going to take like at least a full day. It is an incredibly difficult thing. And that's the part that I found missing when talking to executives about this relationship, is they want to know, all right, well, so I've got all these criticals and highs and mediums, but James, you're telling me that these things don't actually matter, or that they're not actually exploitable. Like, what are my actual exploitable? And that question, you're opening up like, do you expect 1 or 2 or 3 security engineers to suddenly become like vulnerability researchers who can create POC exploits and pen testing their own native app? Like, you're opening just such a, if your goal is like, I want to know what's exploitable, and you're pushing that work on your security team or your devs, it's going to create a ton of issues. And so that's the reason that the divide exists, is because it's really difficult to deal with those details, and you're sidelining a bunch of work. To make it happen in a better place, the first thing I say to every security person is like, you need to commit to a Git repo of a team. Like, if you do not until you open your first pull request with an organization, like, you are not going to have any understanding or respect or ability to speak into the developer workflow. Because you're not really understanding like what their workflow is, the way the app's built, what's happening. And so really that's step one, is like, if I was a CISO, I would encourage my security engineering team, like, open a pull request to the repo, get hands-on, even if you're changing the color of a button, but like, you're learning how to test what the CI/CD is, like what's happening there. And that relationship starts there. But I don't think that's enough alone. You also need, I've tried to do this before without executive buy-in from both engineering and the CISO. And you need, because nobody wants to do security. Like, no dev is waking up excited to patch SCA vulnerabilities. Like, the thing they want to do is build the cool app for the feature that's going to drive revenue. That's what everyone's excited about. So there needs to be, like, it's the carrot and the stick, right? The carrot is the security team is nerdy and working with the devs, and like, they have a good relationship where they understand each other, they're contributing. And then at the executive level, the stick has to be there too, of saying, this is a requirement for our organization. And the way that you build that is by having your security program focused on how is it creating revenue for the business, in terms of a less customer churn because of the trust that's invented with the relationship, and in the form of the compliance stuff that is, first of all, needed, and second of all, it like makes you look like you're never disappointed that one of the tools you use becomes certified like ISO 27001 whatever. Like, you're never like, oh man, that stinks, like they got another certification. Like, it's always good for the company to have those things, and in some cases required, right? Like, PagerDuty didn't choose to do FedRAMP because we decided oh, this would be just a cool thing for us to do randomly. Like, we have customers who need it and who depend on us for critical infrastructure. And so we had to get the compliance that show that we are able to handle that critical infrastructure for people. So it really has to be from the top and the bottom, that it has to be from the CISO and VP of engineering down, but then you have to have the relationship like engineer to engineer as well. And that's why it's such a challenge.
Totally agree. And I will add to that like, one of my sins that I was a developer myself before being a security expert. And when coming from both sides, and you can really understand from one hand the perspective of the developer, like as James said, like no developer wake up in the morning like, yeah, I want to patch all of the vulnerabilities. No, like these guys are working hard and measured upon adding features, generating revenue, and in the end, we're in the business of doing business. Like those guys are measured upon and are getting feedback on the stuff that they get to the product and not on putting down fire. But on other hand, when I'm putting the shoes of the security side, like these guys understand the risk. Their job is to make them fix it. And as James mentioned, it's super different from each and different organization, but every organization still have people involved in the process and from different part of the organization. Like James said, a lot of organization, it might be the DevOps or DevSecOps persona that is like involved with it, and it can be from the engineering side, but a lot of time it's like the security and IT might be involved because it's like the infrastructure. So when we're involving so many like so many different perspective, like a developer thinks differently from a security engineer, and we try to make things work. If we will not go together, as James mentioned, like it should be a joint effort. Like everyone has to collaborate, otherwise it will just make things 10 times more harder, because like we can't expect from like as James mentioned, we cannot expect from a developer to be a security expert and understand everything, and we cannot expect the security to do the job of the developer, because again, it's not scalable, and we talked about it. So I think the way to really bridge the gap, as James mentioned, and really create an operational process that scales, it's to really create those communication workflows of like, okay, you're a developer, usually like what's your biggest pains when you're addressing it? So like, okay, you really have the problem of like, you really need, every time that I give you a vulnerability, you're frustrated by the fact that you need to manually validate. Okay, so let's put you in the middle. Which data do you need when I open the ticket that will help you make this job? And vice versa, when we're, as a security people, open the tickets and they just get ignored, so we also don't feel there's a collaboration. So I think by like really trying to get together and help each other and try to understand, as James mentioned, understand like the real pain points of the other side, and trying like to meet in the middle and make those like another step forward to really enhance the experience of the other part that I'm dealing with. I think this is the key to really scale your OPSEC program, because Daniel, as you mentioned, doesn't matter which tools you have or which technologies you apply or like how your organization is structured. In the end, it's people that are doing those stuff, and people need to work together. Otherwise, it will just bring the gap even wider and bigger. So totally agree, James. Super insightful.
Super interesting. Okay, super insightful. So we try to avoid talking about tools, but we're short in time. So let's open this discussion. So James, when a company is considering a new edition of an OPSEC tool, what, in your opinion, should be their primary considerations in the context of, there are various tools out there, from static code analysis to dynamic analysis. Each of them has their pros and cons. How should companies prioritize, and how can you differentiate between strategies that startups should use versus large enterprises?
Yeah, I mean, that's I wasn't anticipating a good opportunity to plug my side project, but if you go to list.latio.tech, I have a bunch of listings there of really what I have found. I created that list because of this question, where if you go to everyone's marketing site, everyone has the same checkboxes, right? Everyone's a CNAPP. Everyone does runtime protection, vulnerability defense, identity management. Like it's all the same checkboxes. But then when you actually look into the tool, you'll get a very similar demo that's like the dashboard that everyone uses, because everyone's using the same open source stuff to build all their stuff. And so everything looks the same. And really the differentiator comes when it's like, what am I actually going to do with this tool? And the hard part of a demo is you're really setting yourself up for failure because you're looking at a very limited small environment. Usually, like you're creating your own little cluster, your own little host that's going to have low volume of alerts. And you're looking at pre-made alerts during a demo that are like, look, our tool detected this. And it's like, they're not going to show you something it didn't detect. Like, obviously it's going to show in the demo what it did. And the thing that I find that demos almost never move beyond is like, let me show you how we're going to fix this. It's just like, here's what we found. Like, amazing. Now you can fix it. And it's like, okay, great. And so you end up needing like this whole new category of remediation platforms that I'm finding out about only exists because of the difficulties and failings of these tools at scale to really help you actually do anything. And so in a broad perspective, what I try to do is during a demo, during a hands-on, I am picturing the entire workflow from how am I going to get this implemented? Because that's a lift, right? Something, I'm debating calling out specific vendors, but I will. Like something like Wiz is very easy to implement, right? Because it's agentless scanning. There's drawbacks to that, but that's a positive, right? If you're thinking about implementation, is like you're checking the box, you're good. Whereas something else might have a harder implementation, but it's worth it because you're getting better results. And so, yes, you're going to have to work with DevOps to deploy this daemon set to a cluster. But if the results you're getting are actually usable because of it, then that can be a better path to take. And so it's that entire workflow. And I think about that on the runtime side, especially of like, what's the workflow for an alert? What kind of attacks am I going to see get triggered by this thing? And on the configuration side, the thing that I always emphasize is just like, do not buy a tool until you fix a vulnerability that it detected. Like that is a colossal mistake I learned from my first time doing this, because my assessment criteria was 100% focused on lowest false positives, most granular and most reliable detection. And so I was trying to like outsmart the tool and do this nerdy security stuff of like, oh, look, it found the sync. And when I hit it in this other file, and like I was doing all this stuff and like it was still detecting it, amazing. But the tool itself was like unusable from a like developer workflow perspective. And that's because I did a good job like testing all this stuff is found, but I didn't test like, can I fix these vulnerabilities? Am I going to be able to actually make the line go down and to the right, which it almost never does when I look at vulnerability charts. It's always going up, right? And so those are the two things, is like get really granular and thinking about not just when we create these vendor evaluation checklists, we silo it too much into like, what's the security of this tool? Like, is it usable? Can we tune it? Can we change the rules? Can we get the alerts to a Jira ticket? Like all that stuff is great, but it's separating the tool from the workflow of like, what is going to be the best tool that helps us actually complete this workflow from start to finish. So like, here's another good example is like, a lot of CNAP tools, my primary evaluation for those became like starting at the beginning and end of the workflow, where the beginning workflow is like some fresh out of college security analyst is going to be getting this alert saying there's a container escape in a Kubernetes cluster. And they're like, what's Kubernetes? What's a container? What's happening? And so if you just give them an alert, like what comes out of guard duty, that's just saying like this EC2 host had a container, it's like, that's no information. And they're confused because they don't know that that's bad. Like that, they don't have enough information and they don't know that. And so I picture that. And then on the other side is like, when I come to actually fix that, like that's the DevOps team is going to need to reconfigure whatever, to change the privileged container or not, to implement some kind of network policy change. Like all of those things are the output needs to be digestible for them. So something like Sysdig that comes to mind is like automatically generating the network policy or the CNI for the container. Like that is just like a little thing that saves DevOps team time. But like on a security evaluation, you're never going to, I don't care if it's generating a network policy automatically, like, cause I'm not the one doing it. But for the DevOps team, like that's a huge time saver. And so that's what I try to think through is the full workflow and then fixing a vulnerability before I purchase anything.
Great. Thank you so much. Gal, I know you have a lot to say on that topic, but I realize we have only scratch the surface and might not have time for all of our questions today. But for our audience, keep the questions flowing on the chat. If we want to address them today, we will make sure to address and reply offline. Thank you so much, James and Gal, for your rich insights. Now, as we move forward, it's clear, that the right tools and methodologies are pivotal. And Gal, you have played a key role in shaping Oligo Security, which is making a significant impact in this space. And yeah, I would like you to share some more information with us about Oligo and how it helps teams in effectively prioritizing their security tasks.
Thank you, Daniel. Thank you very much. So yeah, I would share the screen. As we can see it. Cool. Can you see my screen?
Not yet.
Great.
There it is.
We have it. Great. So
yep.
Up until now, we were talking about all the theoretical approaches, and that's why we really understand that we have to come up with a practical approach for OPSEC. And that's why from the very first day, we built Oligo to really be practical and really help, because in the end, like, we want to help the security team. And we saw it's like a really huge problem. And like, that's why we thought, like, how can we help those teams to really prioritize the tasks effectively? And like we talked about, the real answer is to really to get this context that is missing today, the deep runtime context from within the application itself, and to really enhance the process that we're doing today. And that's why we did Oligo Security. And this is the first ever runtime context that giving you to do everything by the library level. And what does that mean? It means that with Oligo Security, now you can actually see what's going on within your application. You can see for each and every library, whether it's actually installed of the machine, never been used. Is it actually loaded to memory? But if it's loaded, it doesn't mean that it's actually been running, because if it's running, we can see the functions that are running. And when we look from this perspective at our application, we can see right away that there's a lot of noise that is coming from the theoretical scans, from the static scans, that we don't have the ability to really judge the exploitability of it. And hence, when we look at the numbers, we see those like 85, 90% of just not really exploitable vulnerabilities. It really helps in the process, because we're just removing this noise away, but we're not stopping there. We'll help you to reprioritize the risks that are presented in your runtime by really showing you down to the function level, to the parameter itself, what's actually going on within your application, giving you the real ability to really understand the true risk. And you can see the severity breakdown. And as James mentioned earlier before, it can immediately translate into dev resources getting really freed, and like bottlenecks in development that are today slowing the business itself, the revenue that we're generating. And in the end, like, we do believe that security is essential to really effectively scale, but we want the security to be the brakes of the car that enabling the car to run, and not the handbrake that fully stop everything. And that's why when you really prioritize with that sense, you can really focus on what really matters. But while we do that, we're removing tons of noise that is coming from the scanner. And as we mentioned, and I really like what James said, it really depends on the organization perspective, but the approach that we want to take is not only to tick the box and get to a green dashboard. In the end, we're in the risk perspective, and we really want to protect our application. And that's why we're saying awareness, it's great. But being aware doesn't mean that we're actually protected. And that's why we invented the first ever solution that not only going to show you which open sources you use, but actually show you how each and every open source behaves. And this is Oligo true uniqueness, like not only to show you how an open source can behave or is behaving in your environment, but to actually leverage the crowd wisdom, the network effect, to tell you how the rest of the world is leveraging this piece of code, and by that create the security. And here it's an example of like how this is a real profile of PyYAML, a very famous open source for parsing YAML files. And you can see that from the Oligo perspective, we don't really care if it has a CVE or what's the associated CWE. We solely care that this is a parser that should parse file. And this is what we've seen. It's been done all over. Like we have the data to back it up. And we then compare it to the exploitation on it. And we can see that there is a deviation that shouldn't occur. This is not part of its legitimate behavior. And by that, we create the security controls and tell you, hey, this is a deviation. This is something that we should be aware of. This is exactly when those scenarios in security, exactly like James said, when we start from like trying to remediate risk or fix issues to actually handling an incident. And this is where the level of granularity that was missing in Log4Shell, which basically sounds super simple. Like, I want to know if my duck starts barking. It's that simple. I want to know if my parser that should parse file suddenly connects to the network or suddenly does code execution, which it shouldn't. And this is the true essence of Oligo, to really build the first ever non-intrusive solution that can actually scale into your runtime application. But on the other hand, to do it in a way that really makes sense, because now when we have this deeper level to go to the library itself, this was really changed what people really think about security, as we mentioned, about like why other tools wouldn't, like, or just said that they could block Log4Shell or deal with Log4Shell, but in practice, they're like no one in the world that can do it because they didn't have this level of granularity. So thank you very much, everyone. Thank you, James. Thank Daniel. Thank everyone. It was amazing. I had so much fun, and now I'm taking it back to Mary Lynn to lead the Q&A, but I had so much pleasure, and thank you all for coming and joining this webinar.
Well, unfortunately, we are out of time, but I will have the presenters contact everyone who had a question to get in touch with you afterwards and answer it offline. But thank you so much, Gal and James, for your great presentation, and to Oligo for sponsoring this webcast, which helps to bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.